This is SpaceTime Series 28, Episode 79, for broadcast on the 2nd of July 2025. Coming up on SpaceTime, new samples of Martian rocks intrigue scientists, solar flares being linked to changes in planetary weather patterns, and NASA to gather new in-flight imagery of spacecraft during re-entry. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA's Mars Curiosity rovers just drilled into a new sample of rock from a new region with features that could reveal whether the Martian subsurface ever had an environment capable of supporting life. The new samples are revealing a region of the red planet that scientists had previously only observed from orbit. And the findings are already raising new questions about how the Martian surface was changing billions of years ago. The red planet once had a warm, wet climate with rivers, lakes, and possibly an ocean. However, its water eventually dried up and the planet transformed into the chilly, freeze-dried desert it is today. By the time Curiosity's current location in Gale Crater formed, the long-lived lakes were already gone. But water was still percolating under the surface. The rover found dramatic evidence of that groundwater when it encountered crisscrossing low ridges, some just a few centimetres tall, arranged in what geologists call a boxwork pattern. The bedrock below these ridges likely formed when groundwater trickling through the rock left behind minerals that accumulated in those cracks and fissures, hardening and becoming cement-like. Then eons of sandblasting by Martian winds wore away the rock, but not the minerals, revealing the networks of resistant ridges within. These boxwork patterns stretch across kilometres of a layer on Mount Sharp, the 5-kilometre tall central mountain peak whose foothills the rover's been climbing since 2014. Intriguingly, these boxwork-type patterns haven't been spotted anywhere else on the mountain, either by Curiosity or by orbiters passing overhead. Curiosity project scientist Ashwin Vasavada from NASA's Jet Propulsion Laboratory in Pasadena, California, says the big mystery is why the ridges were hardened into these large patterns and why only here. As Curiosity continues its investigations, scientists will be studying these ridges and the mineral cements used to make them in order to find out whether the current hypothesis on how they formed is correct. Of course, important to the boxwork pattern's history is the part of Mount Sharp where they're found. See, Mount Sharp consists of multiple layers, each of which formed during different eras of ancient Martian climate. So, in a sense, Curiosity is travelling through time as it ascends from the oldest to the youngest layers, searching for signs of water and environments which could have supported ancient microbial life. The rover is currently exploring a layer with an abundance of salty minerals called magnesium sulfates, which form as water dries up. And so their presence here suggests that this layer emerged as the climate became drier. The boxworks patterns are showing that even in the midst of this drying event, water was still present underground, creating the changes seen today. Scientists hope to gain more insights into why the boxwork patterns formed just here, and Mars recently provided some unexpected new clues. The bedrock between the boxwork ridges has a different composition compared to other layers of Mount Sharp. It also has lots of tiny fractures, filled with white veins of calcium sulfate, another salty mineral left behind as groundwater trickles through cracks in the rock. Now, similar veins were plentiful on lower layers of the mountain, including one enriched with clays, but they'd not been spotted in the sulfate layer until now. And that's surprising because these calcium sulfate veins used to be everywhere, but they more or less disappeared as the 6-wheel car-sized rover climbed higher up the slopes of Mount Sharp. Curiosity set out to learn about the unique composition of the bedrock in this area, using the drill on the end of its robotic arm to snag a sample of a rock which scientists have named Altadena. The rover then dropped the pulverized sample into its laboratory for more detailed analysis. Drilling additional samples from more distant boxwork patterns, where the mineral ridges are much larger, will help the mission make sense of what they find. Scientists will also search for organic molecules and other evidence of an ancient habitable environment preserved in the cemented ridges. This is SpaceTime. Still to come, solar flares linked to changes in planetary weather patterns, and a new study by NASA looking at the physics of re-entry into the atmosphere. All that and more still to come on SpaceTime. This episode of SpaceTime is brought to you by NordVPN, SpaceTime's official VPN service. Let's face it, these days your online privacy is more important than ever. Whether you're streaming science documentaries, reading the latest research, or exploring deep space images, you don't want your data to be tracked or your location exposed. With NordVPN, one click is all it takes to secure your internet connection. It encrypts your data, hides your IP address, and keeps your activities safe from prying eyes, whether you're at home, work, or connected to a public Wi-Fi. And here's where it gets really good. As a SpaceTime listener, we have an exclusive offer for you. 74% off a NordVPN plan plus 4 extra months for free. That's right, a huge 74% discount plus 4 bonus months just for being a SpaceTime listener. All you need to do is head over to nordvpn.com/StuartGary. That's nordvpn.com/StuartGary. Not only does NordVPN protect your data, but it gives you access to content from right around the world. If you want to watch a science series that's only available in another country, no problem. Just switch your virtual location and unlock it instantly. And of course, the whole thing is risk-free with a 30-day money-back guarantee. So you've got nothing to lose and your online freedom to gain. So protect your digital life, support SpaceTime, and grab our exclusive offer now at nordvpn.com/StuartGary. That's nordvpn.com/StuartGary. And now, it's back to our show. A new study has uncovered a connection between stellar flares and short-term changes in weather patterns on distant Earth-like exoplanets. Solar or stellar flares are powerful bursts of energy ejected by the Sun or another star. A new study reported in the Astronomical Journal has found the clearest evidence yet of space weather, especially flares from a planet's host star, can cause measurable changes in a planet's climate within just days of an event. These findings provide important clues about the habitability of exoplanets and may even help refine how science understands short-term atmospheric shifts on Earth. The study's lead author, Asef Hochman from the Hebrew University in Jerusalem, says this study highlights an unexplored but important solar climate link. While anthropogenic greenhouse gases primarily drive long-term climate patterns, the new findings are showing that short-term solar variability can also play a role in modulating regional climate behaviour. Hochman and colleagues used advanced three-dimensional general circulation models in order to simulate how sudden flares from host stars would affect the climate on a tidally locked exo-Earth-type planet such as TRAPPIST-1e, a planet which always shows its same face to its sun, much like the Moon always shows the same hemisphere to the Earth. The authors found that upper atmospheric cooling occurs quickly after a flare, driven by radiative emissions from molecules like nobelium and carbon dioxide. Simultaneously, lower atmospheric warming happens due to increases in greenhouse gases like water and nitrous oxide. Meanwhile, wind speeds in the middle atmosphere can intensify dramatically, surging to more than 140 kilometres per hour on the dark night side of the planet. Now, while the main focus of this study was on distant worlds, it has opened up a provocative possibility for Earth climate systems as well. The patterns observed suggest that solar activity may at least temporarily alter a planet's general atmospheric circulation. Now, let's be clear, this is not about long-term climate shifts, such as climate change, but rather short-lived regional anomalies, the kind that could be especially noticeable in already volatile weather zones. The research emphasises that while solar flares are not a major driving force in Earth's long-term climate compared to human activity, their effects are nevertheless real, they're detectable, and they're worth factoring in future atmospheric models. And this is especially true when considering regions sensitive to abrupt changes in temperature and wind. The study also underscores that stars don't just warm their planets, they can also stir up planetary weather systems. And understanding these interactions is crucial to assessing which exoplanets might truly be capable of supporting life. This is SpaceTime. Still to come, NASA to gather new in-flight imagery of a spacecraft during atmospheric re-entry, and later in the science report, a new drug which can cut your body weight by around 25% in just 36 weeks. All that and more still to come on SpaceTime. A NASA team specialising in collecting imagery-based engineering data sets from spacecraft during launch and re-entry is supporting a European aerospace company's upcoming mission to return a subscale demonstration capsule back to Earth from orbit. NASA's scientifically calibrated in-flight imagery SciFly team supports a broad range of mission needs across the agency, including Artemis, science missions like OSIRIS-REx, and NASA's Commercial Crew Program. The SciFly team also supports other commercial space efforts, helping to advance space exploration. Now, SciFly intends to gather data on the European exploration company's Mission Possible capsule when it returns to Earth following its launch on a SpaceX Falcon 9 rocket. One of the key instruments being employed by SciFly is a spectrometer that detects light radiating from the capsule's surface, and that will allow scientists to determine the surface temperature of the spacecraft. Now, traditionally, much of this sort of data comes from advanced computational fluid dynamics modelling of what happens when objects of various sizes, shapes and materials enter different atmospheres, such as those on Earth, Mars or even Venus. SciFly's capability lead, Carrie Scott from NASA's Langley Research Center in Virginia, says while very powerful, there is still some uncertainty in these computational fluid dynamics models. And real-world measurements made by SciFly will therefore help NASA researchers refine their models, meaning better performance for sustained flight, higher safety margins for crew returning to Earth from the Moon or Mars, or for landing more mass safely while exploring other planets. Right now, SciFly members are being staged in Hawaii during the re-entry, and they'll fly aboard a specially kitted out NASA Gulfstream 3 aircraft, monitoring the capsule's descent over the Pacific Ocean. Aboard the Gulfstream, SciFly have fitted the spectrometer as well as an ultra-high-definition telescope, both of which will be trained on the re-entry vehicle. But these observations will be challenging, as the team will be tracking the capsule against the bright daytime sky. Now, scientists expect to be able to acquire the capsule shortly after its entry interface point. That's at roughly 200,000 feet. It's where the atmosphere becomes thick enough to begin to interact with the capsule, producing compressive effects such as heating, a shock layer, and the emission of photons, mostly in the form of plasmas. Now, in addition to the spectrometer data on the vehicle's thermal protection system, SciFly will also capture imagery of the parachute system opening. First, there'll be the small drogue chute deploying to slow the capsule down from supersonic to subsonic speeds, followed by the deployment of a main parachute. Lastly, cloud cover permitting, the team plan to image the splashdown in the Pacific Ocean, which will help the recovery vessel reach the capsule as quickly as possible. This report on the project from NASA TV.
NASA's Langley Research Center is a leader in developing advanced entry, descent, and landing technologies that enable both crewed and robotic missions to land safely, whether on distant planets or during return to Earth. A vital part of our effort is NASA's scientifically calibrated in-flight imagery team, or SciFly. SciFly uses ground-based sensors and instruments flying on various aircraft to image parachute tests, launch abort systems, sample returns, rocket launches, and spacecraft re-entry. Computational tools and wind tunnel tests allow engineers to predict how a vehicle will perform. The data SciFly captures lets us see how a vehicle actually performs in flight, and by comparing that performance to what was predicted, we can improve our models and our computational tools. Our current mission is a partnership with the Exploration Company, a European aerospace company developing spacecraft for future exploration. A subscale demonstration capsule will launch into space and return after orbiting Earth. SciFly will use aerial assets to capture visual performance data for the spacecraft's heat shield and parachute system on re-entry, and give their engineers critical insight as they scale up for their next spaceflight. Imaging spacecraft traveling at extremely high speed from a safe distance requires extensive planning. So when we successfully acquire and track the spacecraft as it is entering the atmosphere at high speed and from great distances, it's incredibly rewarding to know that we've contributed to the bigger mission of safe and successful entry, descent, and landing, and the advancement of human spaceflight for all.
This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new drug called amycretin has shown that it can help reduce body weight during 2 early-phase clinical trials. A report in the Lancet Medical Journal found the drug, which targets both GLP-1 and amylin receptors to help control blood sugar and appetite, was reported to reduce body weight by up to 24.3% when injected over 36 weeks and 13.1% when taken orally over 12 weeks. But it wasn't all good news. That's because the trials also found that amycretin did cause a moderate to high frequency of gastrointestinal side effects, including nausea and vomiting, as well as a lack of appetite. The authors suggest that this drug could be a promising treatment for being overweight or obese, as well as type 2 diabetes. But they say larger trials will be needed in order to confirm these early findings. It's also important to note that the study was funded by the manufacturer of the drug, Novo Nordisk. Scientists have discovered that killer whales living off the west coast of North America were spotted making use of tools in order to groom each other. A report in the journal Current Biology claims the authors observed the whales breaking off the ends of bull kelp stalks and pressing those pieces of kelp against each other and rolling it across their skin in what appears to be a grooming activity. The authors say that while there's plenty of evidence for land animals such as elephants, birds and primates using tools, examples of tool use like this from marine mammals is rare. A new study reported in the journal PLOS ONE has discovered how the popular artificial intelligence chatbot ChatGPT responds to non-words. Non-words are meaningless collections of letters and sounds used in cognitive psychology to explore how humans learn, remember and process language. And the authors wanted to know how the black box of ChatGPT might react to similar experimental prompts. They found the artificial intelligence finds patterns, but not necessarily the same patterns humans would use to do the same task. ChatGPT showed that it could provide correct definitions for many actual English words that are no longer in use. Of 52 carefully chosen extinct words, ChatGPT responded with 36 correct definitions. For 11 words, ChatGPT responded that it couldn't recognize the word. For 3, the chatbot gave definitions gleaned from words in foreign languages. And for 2, ChatGPT appears to have simply made up the answers. It lied, so-called hallucinations, in order to respond to the word definition requests. The Australian government's now looking at including YouTube in its digital bans designed to prevent kids under 16 from accessing social media. The censorship czar, e-safety regulator Julie Inman-Grant, claims the survey she's undertaken showed that 37% of 10 to 15-year-olds who had used YouTube had seen or heard potentially harmful content on the platform. Critics, however, warn the planned bans are all part of a surreptitious government strategy designed to force all Australian citizens into a digital ID system. People have previously rejected attempts by the government to introduce an Australian ID card because of its Machiavellian Big Brother implications for people's freedoms. The digital age verification software is being seen as a backdoor by the government to introduce the scheme by stealth. With the details, we're joined by technology editor Alex Zaharov-Reutt from Tech Advice Start Life.
Yes, well, this is where YouTube is slated to be included in the social media ban, even though YouTube has come out and decried this as being against what the government originally wanted to do. They're saying that this recommendation is in direct contradiction to the government's decision to exempt YouTube from the ban. I've read reports that are saying that, look, people are going to be able to get around it. Kids will get around it. Parents will allow kids to use it. So I really
just
don't
get around
know.
it with a VPN?
Well, in theory, you could, yes. And seeing videos online where people are putting on these masks that you can obviously buy that give you a much older looking face and they look real. I mean, how is a age verification technology meant to discern from someone who's 15 years and 364 days to someone who's 16? I mean, it's sort of crazy. I mean, it all comes down to, is this a pathway to digital ID, everything you do being tracked online, and some sort of a kind of dystopian nightmare where you're going to need, you're going to need permission to do anything. And of course, if you go the logical step further, I mean, once
you'll have social credit points like they do in China.
Well, that's exactly right. But I mean, worse than that, the social credit points will be linked to a digital currency from the central bank. And then if the government doesn't like what you're doing, they'll be able to say, like in China, that you can't board this plane or board this train, you can't buy these sorts of things.
Or they can freeze your bank account like they did in Canada.
Well, like they did with Nigel Farage in the UK.
That's Alex Zaharov-Reutt from Tech Advice Start Life. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.